Welcome to this course on machine learning for finance, algorithmic trading, as well as investment. Now, this course is a brief introduction to machine learning with the application to finance, as well as investing, the modeling technique, as well as model validation. So in this lecture, what I will cover is the different areas of machine learning and how it actually apply to finance. Specifically, I will be providing examples on how you apply machine learning technique on trading strategies as well as some of the areas of finance. But bulk of it is really on how to use machine learning and incorporate it into trading strategies. Let me just give you some backdrop. First of all, a quant or hedge funds or fund managers are always looking for alpha. At the same time, they're looking for strategies that's uncorrelated to the previous or existing strategies that they have. They are more and more employing quantitative strategies to actually speed up the process, as well as to actually look for unused or untapped strategies. So they have moved beyond traditional investment strategies to look into systematic investment strategies, cross assets, as well as risk premium investing, such as your value, your momentum, quality, volatility, as well as growth. These are the common 5 factors that are used. But more importantly, this has been around for the last 10, 20 years. Hedge fund managers are increasingly moving towards an area that's relatively untapped. Over the last 5, 10 years, there has been a big data revolution. There has been a massive increase in data captured, the access to low-cost computing power, as well as data storage capacity, and the last, but not least, is the advances in machine learning, as well as the deep learning technology. These has brought about the big data revolution, which really is impacting massively in the fund management industries. So I just want to cover some basic categories of machine and deep learning, just so that we actually have a common picture of this. Machine learning, or the traditional machine learning, typically are classified into supervised and unsupervised. If you look at supervised machine learning, it's basically inferring a function from labeled training data. What does that mean? That really means that you are trying to actually come up with a function or equation, in a more traditional term, from labeled training data. You have a set of data. Take, for example, probably the best way to illustrate this is age versus height. Age being your so-called independent variable, your height being your dependent variable. So these are the training data that you provide to the algorithm and train it. So these are all labeled because you provide them with a specific linkage between the age as well as the height. There are 2 subcategories of supervised machine learning. There is the regression base, which is a continuous variable, and also classification, meaning it's either 0 or 1, yes or no. And then there is the unsupervised machine learning, where no labels are given to the learning algorithm. You leave it on its own to find the structure. Okay, so there are 2 categories of these. There's the clustering, where it actually clusters the categories on its own, whereby there are some similarities. It put them into different buckets of its own, or dimensionality reduction, whereby reducing the high dimensionality, especially if you're looking at more than 3 dimensions, it's difficult for human to actually decipher where the actual relationships are. Quite often you use these strategies or these techniques, machine learning techniques, to reduce the dimension. The third category that's really receiving a lot of attention over the last 2-3 years is the deep learning area. So here you have the artificial neural network, the convolutional neural network, recurring neural network, and finally the reinforcement learning. These we will go into a little bit more in future classes. So I just want to give you another picture of these. So you have the supervised, the unsupervised, as well as the deep learning. So under regression, you have the linear, the lasso, the ridge, the KNN, as well as the XGBoost, the very popular XGBoost. And you have the classification-based supervised learning. You have the logistic, you have the support vector machine, you have the random forest, hidden Markov. All of these have been implemented, and I'm going to show you how it's used in the finance and also investment space. The unsupervised learning, where you have the clustering such as k-means, Ward, mean shift, and a few others, as well as the factor analysis such as PCA and ICA. And in deep learning, there's also the time series and unstructured. Deep learning right now, it's very popularly applied in text or unstructured text. I'm trying to extract meanings out of that, as well as images. So these are the two areas that is actually most used. But I'm just going to show you in future lectures that there are other ways to actually apply deep learning in the finance space. So since this is a combination of machine learning and finance, I just want to give you a heads up, a little bit of the lectures that I've created or creating as well for some of these, so that you can have something to look forward to. These are all different lectures, and because there are so much content, one built on top of the other, I just want to talk about these specifically on their own, as a course on their own, so that you can actually look into them and the different areas that you're interested in. The first one is really this lecture here is an introduction to machine learning on linear regression and also financial time series. Obviously, when you're applying the traditional machine learning in the domain of finance or trading, you have to bear in mind the so-called idiosyncrasy that comes with financial data. It's vastly different from your normal data that comes from whether it's retail or business data. Financial data time series and time series has vastly different characteristics that you have to be mindful of. You can't just take any machine learning strategies or techniques and apply it to the financial time series and expect it to perform the same. The second of these series is machine learning for algorithmic trading. In particular, the specific areas that we're looking at is pairs trading. I'll be using linear regression to start with, and then followed by some of the penalized so-called learning or linear strategy or penalized regression techniques such as ridge, lasso, elastic net regression, as well as a state space model, which is the common filter with particle filter. And the third of these video series is machine learning for multi-assets trend following strategies. This is in the example of so-called cross-asset momentum strategies, whereby we used regression technique and apply it to predict the returns of S&P 500, 7 to 10 year Treasury bond index, the US dollars index, as well as a commodity such as gold. The XG Boost, I'm going to talk about it in this category. I have not implemented it in its full extent, which including backtesting. I have run it and backtested offline, but I have not implemented it. But I'm still going to talk about the strategy so that you can actually try it out as your own home exercise or homework. The fourth of these video series is classification-based machine learning for algo trading. What has been implemented is logit or logistic regression, the LDA, the QDA, all of these to predict the next day's return. And there's some really exciting so-called results that come out of these. The fifth of these is ensemble machine learning for algorithmic trading. I'll be using random forest classifier, combining global 14 factors for stock selection. So this is a fairly drawn out strategies. I'm going to walk you through it step by step. There's actually a lot of contents there as well. And within this, I'm going to also show you AdaBoost as well, which is another ensemble machine learning, and how it actually is being used by quant hedge funds, and they've demonstrated it. And I'm just going to walk that with you, walk through the process from designing the model all the way to actually backtesting it and look at the results. Step 6 here is the unsupervised machine learning using hidden Markov model for algo trading. Again, this has been implemented. I'm going to share with you the codes. You can get all of my codes via my GitHub. I'll show you and the individual course itself. And the seventh of these is clustering and unsupervised machine learning for investing. Typically, you use this unsupervised or clustering technique not necessarily directly for generating signal, but you use it to actually help you generate signal or modify to generate signal to help you to actually categorize, for example, different so-called sectors. Typically, we just take the sectors category from Morningstar or MSCI, but you might want to actually do your own, apply your own clustering technique to actually extract some of the so-called hidden information in there. I'm just going to show you stock market visualization using some of the so-called sentiment data and apply clustering technique to it.